Hello friends, I welcome you in lecture number 3 on estimation. In previous lecture we have discussed about large sample estimation of a population mean, and we have seen how we can find out maximum error of estimate using the formula E equal to Z alpha by 2 times population standard deviation over square root of n. Now in this lecture we will discuss one question related to this, which was asked in GTU Winter 2020 exam. So first we understand this question. In a study of automobile collision insurance costs, a random sample of 80 body repair costs for a particular kind of damage had a mean of 33065 rupees and a standard deviation of 4364 rupees. If x bar equal to 33065 rupees is used as a point estimate of the true average repair cost of this kind of damage, with what confidence can one assert that the error does not exceed 700 rupees? So here we are given that mean of a random sample is x bar equal to 33065 rupees and sample size is 880, and it is given that sample standard deviation is 4364 rupees. Okay, this is the standard deviation of a sample. So that we denote by S equal to 4364, and the size of sample is 80, which is large enough, and we are asked to find out the confidence level. Here we are asked that with what confidence one can assert that the error does not exceed 700 rupees. So we are given the maximum error of estimate as 700, and we have to find out the level of confidence, that is we have to find out 1 minus alpha. So how to find out 1 minus alpha, that is level of confidence or confidence level? That is the question in this problem. Now if we recall that formula for maximum error of estimate is E equal to Z alpha by 2 times sigma over square root of n. But if we don't know what is the population standard deviation, that is if sigma is unknown and if sample size is large enough, that is if n is greater than or equal to 30, then we can replace this population standard deviation by sample standard deviation S. Here size of sample is 80, that is we have a large sample, so we can use this formula for maximum error of estimate. Now here we are given the maximum error of estimate, but we don't know what is the level of confidence. Using this formula we can find out the level of confidence. So first we write that here sample size is large, or we have a large sample size is large, therefore maximum error of estimate is E equal to Z suffix alpha by 2 times sample standard deviation divided by square root of n. We are interested in the confidence level. For that, first we find out value of Z corresponding to alpha by 2 using given quantities. So Z alpha by 2 will be equal to E times square root of n divided by S. Therefore Z alpha by 2 equal to value of E is 700, sample size is 80, and sample standard deviation is 4364. So therefore Z alpha by 2 is, using scientific calculator, I obtain this as 1.4347, and if I round off to 2 decimal places, I can write Z alpha by 2 equal to approximately equal to 1.43. Now we are interested in the value of 1 minus alpha, that is level of confidence, so that we can obtain using this value of Z alpha by 2. Now if we observe the standard normal curve, suppose we have Z alpha by 2 somewhere here, then this area which is to the right side of Z alpha by 2 is alpha by 2. Okay, so we can say that probability that Z exceeds Z alpha by 2 is equal to alpha by 2. Therefore probability that Z is greater than, here Z alpha by 2 is 1.43, this is equal to alpha by 2. Now this I can rewrite as 1 minus probability that Z is less than or equal to 1.43. So this is equal to alpha by 2. This we can obtain using the standard normal table. We can use cumulative probabilities for standard normal. So we will find out values of Z corresponding to this. This we can rewrite as 1.4 plus 0.03. So under the column of Z, I search for 1.4. So here I have row corresponding to 1.4, and I will search column corresponding to 0.03, which is this column, and if I take intersection of these two, I will obtain 0.9236. So that is the probability that Z is less than or equal to 1.43, and it is equal to 0.9236. So that we substitute here, probability that Z is less than or equal to 1.43 is 0.9236. so that we substitute here, this is equal to alpha by 2. Therefore alpha by 2 equal to this subtraction is 0.0764, and therefore alpha will be equal to 2 times 0.0764, which is 0.1528, and we are interested in the confidence level that is given by 1 minus alpha. So we subtract this from 1 and we obtain that 1 minus alpha is 0.8472, or we can write in the percentage. So the confidence level in percentage form is 1 minus alpha times 100. So this is equal to 84.72%. So here we are asked the confidence level. With what confidence can one assert that the error does not exceed 700 rupees? So we can write that with 84.72%, with 84.72% confidence, one can assert that we have to write whatever is asked in the language. We can assert that the error does not exceed 700 rupees. One can assert that the error does not exceed 700 rupees. So here we were given the values of maximum error of estimate and sample standard deviation and sample size, and using this formula we are able to find out the confidence level which is given by 1 minus alpha. So this question was asked in GTU Winter 2020 exam, and I have tried to answer this question. So I hope you like this lecture. Thank you very much.